So all the data that we accumulated, we actually put into this wonderful computer, and it jumped up and down and turned it sideways, and it spit out some correlations. The correlations we came up with were actually very interesting. This is the percentage of chemicals present when methane is present. And what we actually determined was toluene was present 94% of the time that methane was present. And MNP xylenes were present 86% of the time, dichloroethane was 80% of the time, benzene, et cetera, et cetera, et cetera. This tells you that if there's methane, chances are you're going to see something else. That's all it tells you. It tells you that toluene is almost always there. So this is good to know. So we have a parameter of what are the chemicals that we're going to be seeing consistently. And again, this could go on and on. I stopped at 50%. So I brought you an idea, because this is like, okay, this is chasing little invisible butterflies is what I do for a living. And it's real difficult for people to say, but I can't see it. So what I brought today is a little bit about the city of Dish and what happened in the city of Dish. This is our little case study. The city of Dish has a compressor station. It's not just one, but there are 5, side by side by side by side. They do this so that I can't figure out where it's coming from. I've got the emissions tracked, but they say, well, who did it? And I'm like, I don't know. There's 5 of them right in a row, side by side by side. So I can't blame that guy because this guy has emissions too, and I can't blame that guy because this guy has emissions too. And I look at TCEQ and I go, I don't know. And they look at the Railroad Commission, the Railroad Commission, not me. There's an MOU here, a Memorandum of Understanding. We don't do air emissions, that's TCEQ. In the meantime, the people are choking. I don't know. We can't do anything about it when they go side by side by side by side, 5 different companies. You cannot isolate emissions that way, and therefore you cannot isolate fault. Brilliant. Next slide. So what we have right in the middle of that bullseye are the 5 stations side by side. What we have surrounding that is a residential area in Dish, Texas. This is the infamous Dish. If I had known about all the trouble I'd be in from Dish, Texas, I wouldn't have agreed to test there. But anyway, so the inner circle is what we're looking at right now. The red point on the inner circle is where I set our monitors, and I monitor for 24 hours. I want to know, out of 24 hours, what kind of emissions did I get out here? What chemicals did I see? And what we determined was we had a fairly high concentration of methane, so we know we're getting lost product. Talked to one of the CFOs of one of the big companies, one of the big gas producers, and I said, why are you guys not capturing the methane? He goes, I don't know. I've been telling the guys, the technical guys, for years, we're losing millions of dollars. But it does come down to dollars and cents. Is it cost positive to actually go after the product, or is it not cost product? You know, and that's what they have to determine. So they've determined so far that there are different processes, and there's still going to be lots of leaks with this. So we've got methane. We've got benzene at a low amount, though. That's not really high. That's not something that I would get really excited over. And again, these are 24-hour concentrations. We'd have to calculate them, do a little formula recalculation in order to determine what they are for a 1-hour concentration. We've got dimethyl disulfide down there. Look at that. That's 52. These are in parts per million. I'm sorry, parts per billion by volume. So that one's a little high. But overall, I said, you know, we count product, we count emissions per chemical, but what's the cumulative effect on people? Well, the cumulative effect is people are getting sick. Now, I can't tell you which one of those chemicals is getting them sick, but I can tell you it's a bad soup. So then I said, all right, let's go out. Oh, by the way, the first dot is about 2,150 feet. So I said, let's go out another few feet and measure further on. I mean, I would love to have done 10 of these. They're expensive, so I could only do 2. But then we measured another 1,000 feet out in the next slide. The other 1,000 feet out, we came up with methane had reduced to 2.1. There's a process where the atmosphere basically moves. Nothing is static in the atmosphere. It's here 1 minute, on it again. Benzene went up to 12.30 parts per billion. But that's, again, a 24-hour concentration. It turns out to be somewhere around 30 parts per billion when you calculate it to a 1-hour comparison of of the TCEQ's 1 hour comparison. It's not a good thing. And we just went on and on. We've got toluene at 61.7. We've got the benzenes, MMP xylene, excuse me, at 46.2. This is where we started to see really sick people. And how far out did I say we were?
3,150.
About 3,100 feet. Shocked my shoes off. I mean, I knew that people were sick, but this was concerning. Go ahead. So we went back to the lab and we put this into a Lakes air mod. And basically air mod is a computer formula where you can make a map based on those reading of chemicals, based on what you're looking at as far as the production and volume, etc. This is not developed by me, by the way. This is developed by somebody else, Lakes Environmental. Great product. This is one of the chemicals, and what we're looking at on the right-hand side is basically the concentration in which you exceed TCEQ's effects screening level, which basically it says, you know, at this point we should investigate because things maybe aren't as good as they should be. Most of what we're looking at is a mile distance. Right in between is our point source. That red part is actually where the stations are. And as we go out, there to that first line is approximately a mile. So what we're looking at, as you can see, is the concentrations of chemicals in that area exceed TCEQ's ESL for 1 hour considerably over a year's time. This is a long-term exposure. This is one chemical. Go ahead. This is another chemical. It happens to not flow as far, and I'll use that term flow. In actuality, air rises and air falls, but in some way it disperses, so it doesn't flow as far. This is a heavier chemical, doesn't want to go quite as far. Next. This is one of our carbon sulfides. As you can see, it flows really far because it was completely off my map. And we are at 640 micrograms per meter cubed, which is the same as ppb. Anyway, close enough. We are way off. I mean, we are way off on this map. Go ahead. So, what are the effects? What are we seeing as the effects? Again, those chemicals are per chemical. When you put them all together, well, maybe it is like a really bad college alcohol punch or something. Not that I ever drank that stuff. But anyway, garbage can punch where I guess they say it's really bad the next day. So it's not like you've got a nice beer. It's like you've got a whole bunch of stuff really poison you. So some of the physical effects I wanted to show you.